many, many, many years ago. This is like 20 plus years ago. Did a lot of jujitsu and had my arm hyperextended a number of times.
Yep.
And like many men of younger vintages, felt I was invincible. So I would ice it, wrap it, and just go straight back to the gym like an idiot. Now that has come back to haunt me, and I love climbing. I'm not particularly great at it, but what happens is I take a long break, usually a few years, then I come back, I start climbing. Everything is great until I get to about 511A, where I start having these harder, for me, crimps, right? And at that point, my elbow goes absolutely berserk in that lateral epicondyle area. I think there's also some damage in the joint or joint capsule itself, but let's put that aside for now. I also have quite a bit of pain kind of lower tricep near the elbow. But then I take a long break, I go back, and the process repeats itself.
Yeah.
Then I got very excited about fixing this with isometrics. And I thought to myself, okay, and we may not have time to dig into this, but I do have questions about collagen and vitamin C. So I've been taking hydrolyzed collagen peptide powder. We can talk about whether that checks the box or not, with vitamin C about an hour prior to doing isometrics. And then I've been varying, because the internet has different things to credit you with, and I don't know which are correct. One is I don't have proper tools here, but I'm using basically a cast iron pan. And you can, for people listening, you can imagine I'm holding this in my right hand. The pan is pointing straight up. My elbow is by my side. And then I'm rotating so that the top of my hand is up and holding it in that, there's probably a better technical term, but kind of internally rotated position, holding that for 30 seconds and then taking 2-minute rest, another 30 seconds, and doing 4 total rounds of that. I've done that. I've also experimented with having my arm flat on a table and then pushing down on the top of the hand. So it's effectively like holding a reverse curl, you might think of, and have played around with that. What should I do to fine tune that? What are your thoughts?
So this is one of the reasons that one of my postdocs and I are actually starting a small company. We just spun out a company because
Look at that.
What we're always doing is we're trying to figure out, how can I do this with a bunch of stuff that's not well suited for it? And so what we're doing is we're designing devices, and then we're instrumenting them so that you can see how much load you're putting through it. And you can then understand, like, okay, I'm going to do this repetition. Here's my strength curve. Okay, there's my 30 seconds. Okay. Until those things are out, basically what we would say is you're trying to do exactly what you're saying there. First of all, when you have injury, what we're trying to do is we're trying to keep the kind of the pain on the scale of 1 to 10. We're going to try and keep it at 2 or below. Because what we want to get is we want to get load through there, but without getting too much load. We don't need a ton of load, remember. So that's what the Abrahams are good with. And there, you can start even with 40% of body weight. And it's independent of the load. And so as long as you can get load through the tissue, that's fine. So if you have a really big damaged thing, basically your cast iron pan might be a little too much. And so you might be overdoing it a bit and getting a little bit more of the signal to the wear, which is what we're looking at. So what's your ratio of signal to wear? And we're trying to maximize the signal with minimizing the wear and tear.
Yep.
And so what we would do is, the other way to do it is to just take a tennis racket and find like a door jamb or something and just put it underneath and just do the opposite.
I see. Right.
And then you can do that in both directions.
Or a golf club. I've seen demos with that as well.
Exactly.
Or under a kitchen island like I have in front of me here.
Yeah.
I got it.
So
you'd basically be pushing against it as an isometric.
Yeah. And so that's called an overcoming isometric, because you're trying to overcome something. And the important thing there, and the reason that I like what's called an overcoming, think of it like a leg extension. When you're starting with your knees both bent, you haven't touched the little pad down there to start extending your legs. Now I put my feet against the pad and I'm going to extend out. I have to try and overcome the weight. If I put the whole stack of weight down there, it's an overcoming isometric. The reason that we like these overcoming isometrics versus what you're doing a little bit with the pan,
lowering the pan,
which is called a yielding isometric.
Yielding isometric. Okay.
A yielding isometric is basically the way of thinking of it is going back to the leg extension. I'm kicking out with 2 legs, and then I'm taking the weight onto 1 leg. Okay.
Yep.
And I'm holding it with the 1 leg. So those yielding isometrics, we're going to get a lot more load.
Yep.
But again, that's not necessarily the key component that we want to start with. We'll want to build to that. But at the beginning, we need to make sure that we're controlling the load. What I like about the overcoming isometrics is I can have you now, instead of going like hold the pan and you have to immediately hold it and you get jerk.
Yeah, you totally.
At that immediate part. Now what I can do is I can minimize jerk. And so what I'm going to do with the overcoming isometric is I'm going to say, I want you to develop force over 3 seconds. So I want you to start nice and light. Just feel the pad on that leg extension. And I want you to slowly try and extend your leg until you get to your maximum force. And then I want you to hold it there for 30 seconds. And then I want you to slowly let it off. And now what I've done is I've decreased that wear and tear component as low as I can. And I'm maximizing my signal component because I'm going to do that 30 seconds. I'm going to do a 2-minute rest, and I'm going to do 4 of those. And now that's going to give me 8 minutes. So 10 minutes of work, 10 minutes of activity on that one tendon I'm looking for. And that's going to give me all of my signal and a very, very small amount of wear and tear because I've minimized jerk. I've gotten the signal into the cells. And basically that signal is just like, oh, look, there's load and the load's coming from that direction. Because the reason you get a scar is it doesn't feel the load. It doesn't know where the load is. So it puts collagen out in all kinds of different directions. When the load comes through, now it goes, oh, we just have to make it this way. And it makes all the collagen in one direction. Now you can fill in your scar because now you can synthesize collagen in a directionally way that's going to meld up with the whole tissue from the beginning. And now we can regenerate that tissue pretty complete.